Hello guys, welcome to my channel. Let's see encoding using n-k bit shift register. Previously we see how to calculate that code vector or code word in mathematical way. We'll see how to generate using like a practical way, like with a circuit. So basically how to implement, I will tell you how to do. I will tell you using a problem. Let us take a problem here, that is a 7,4 binary cycle code generating by a generator by g of x, that is 1 plus x cube, and verify its operation using the message vector. These two vectors they have given. So first they have given a generator matrix, that is 1 plus x cube. When you compare it with original g of x, that is g0 plus generalized g of x, that is g0 plus g1x plus g2x plus so on gn minus k x power n minus k. So here 7 minus 4, that is up to 3 it should go. Up to g3 we need to write. So when you write g0 coefficient is 1, sorry, that x power 0 coefficient is g0, that means 1, and here g1 is 1 because x coefficient no 1, and x square is not there here, so g2 will be 0, and x cube coefficient is 1. Right, we got these terms. Now next we need to draw the circuit. So for the circuit, how to draw is basically there will be resistors. Okay, so first we need to do number of resistors here. So how to know how many number of resistors we'll get? Basically there will be n-k resistors, n-k shift resistors, right? That's why as the headings only says, that is n-k shift resistor. So basically n-k we need to have. So no, so initially that is 7,4, that means n is equal to 7, k is equal to 4, and n-k is 3, right? So we'll have 3 resistors, or let us random. First we'll write the boxes, then we'll 3 resistors we have. So I'll name it as R0, R1, R2. Now we found out G0, G1. Where to place that? We'll see G0, G1, G2, G3. So first, in between every resistor there will be one modulator adder. They will be connected like this. Okay. After this also there will be a modulator adder at the end also. I will tell you why. Now there are G1, G2. So first the G0 will be coming to directly R0. Now from G1 it will be coming to the modulator G1, and this will be G2, and this end, that means here this it will be upwards. Okay, that is G3. Remember the directions also. So here I will tell you how it works, then you will be understanding how the direction of arrow should be. So here there will be a gate, AND gate will be there, AND. One of the input is called enable pin. Now what happens, this is all G's and all connected to this one. Okay, actually here G2 value is what? G1, G0 is 1, G1 is 1, G2 is 0, G3 is 1. So as since G2 is 0, we don't need to draw this line. Okay, so no need to draw this line, and also no need to have that modulator adder, because nothing is added. Only one input is there, that is only going. So that's why no need of adder also in this case. In previously I told the generalized way. Now in this question 1 1 0 1, right, for G0, G1, G2, G3. So G2 is 0, we no need to write the connection here. G0 is 0, this is 1, G0 is 1, like that. Here G3 is also 1, that's why I have connected. Okay, basically don't think that G3 will be 0, because definitely there will be highest x power n minus k term. Definitely it should be there, it will be there. And now of the diagram, now where are the inputs I have to give? I have to give inputs, right? So how to give? I'll give inputs to here, that is data. Okay, now I need to get output. The output will be like this. Okay, here this will be like this. So basically this looks like this. The output is directly coming from here and data will be entering here. So basically we need to write what we need to write here. There will be a commutator. Initially it will be connected to the down data bits. So what will get the data first? If it is 1001, what happens? I'll draw here. So when it is 1001, the first bit is 1, right? So one by bit bit, so bit by bit it will go. So first bit is 1, that's why here it will be 1, and the 1, so that one only will be forward here. Okay, that is 1. In this is a channel, basically this is going to channel. Now initially what you have to do in the registers, the initial values will be 0 0 0. Okay, all the values initially they will be 0 0 0. So the R2 output also 0, so 0, because whatever in the R2 it will be coming out of here, right? Because this is the shift registers. So R2 will be coming to here. The 1 is here. 1 XOR 0 is 1, and also again anyways this one only be, so it will be 1 here. Okay. And enable pin, initially enable should be 1 only. Until all these bits enter this circuit, the enable pin will be 1. So when the enable pin is 1 and this is 1, 1 and 1 is results to 1. So basically this line here, if you this is a block of G1, G2 like that. Okay. Now what happened? This one is entering here, and G0 is also 1. That's why basically it will pass. Okay. If it is 0, for example, this value is 0. 0 into 1 is 0. So nothing will be coming to the R0. Like coming to value is 0 only. You will get 0 or the R0 only. Because you understand. Okay. Basically it is like a cascaded way. For example, this is G0 is equals to 1 and the input is 1, we will get 1 only. If in the same way G0 is equal to 1, if input is 0, we will get 0, like that. So when it is 1, what happens? 1 will be passed over here, and initially what is the value of R0? Initially these values are 0, right? 0 0 0. Now when the data is coming as 1, what happens? This when it should be empty, then only it can come. So what it will do? It will shift. It will move this data, previous data, that is 0 to here. And anyways, 1 and this block here also 1 only will be there, right? So what happens? 1 XOR with 0. Okay, 1 XOR with 0, that is 1. So here it will be 1. That means the value that is being entered to R1 is 1. So what to enter into the register, this should be empty. That's why this this 0 will be shifted here. Okay. Actually there should be a modulo to adder, but there is nothing here because G2 is 0. That's why the same contents of R1 will be moved to R2. So at R2 it is 0 only, right? At R2 also 0. Now what happens? This 0 initially here it should be entered into this. That means this 0 should be coming out. So it will be coming out like that. So initially what is the value of R0, R1, R2? In the now the values are 1 1 0. Okay. So now if I am trying to send the next bit. Okay. So I will try to send the next bit. For example, if I try to send wait, I am taking a razor and write. Okay, now I take this. So what are the values now? 1 1 0. Now if I try to send 0, because this is over, already completed. Now I will try to send 0. It is 0, here also 0, here also it will be 0. Okay, so already 1 0. This 0 will be here. So what is the value waiting at this line? That is 0, right? So 0 XOR 0, that is 0. So that's why we will get 0 here. 0 XOR 0 is 0, that's why we'll get 0 here. One of the input is here. 1 and 0 is will be getting 0 as the output here. Okay, so I'll change the color, you will understand. So it will be 0 and this will be 0, that 0 will be here. So basically 0 into gain here, that generated polynomial coefficient, that is 1. So 0 1 will get 0 only, right? 0 into 1 is 0. So now what is the value present at R1? This. So this will be shifted here, right? 1, and again 1 XOR with 1. What is the value? Oh, not 1. Actually what happens, 0 into 1, that means it will also become 0, right? 0 into G1, that is 0 again. So 1 XOR with 0 will get 1. So what happens, this now the value in R1 is 1, this will be moved to the next one. So when it moves to here, that means R1 is R2 is also 1. Okay, now R2 is also 1. The value available at sorry, so now this will be coming outside. So now the value is 0 1 1, right? So let's check with the table itself. So see 1 1 0 0 1 1 we got. So for the first cycle we will get 1 1 0. When second bit is sent, that is second bit 0 0 1 1 we got. Again the another 0 if you send, this is also completed. Now if I try to send the next bit, that is 0, the value will again 0. Why? Because 0 will be cutting. Now now what is the value of R2? 1, right? That's why now again I'll rub it. You understand, right, how I am writing? Okay, okay. Now this 0 is coming here, so it will come here, already I wrote. So now this 0, what are the values present here? Now 0 1 1, right? So this one is coming, will be here. So 1 XOR with 0, that is 1, that is passing here. The value is 1 and 1 1 is 1. So again normal, again that 1 will be sent, because 1 into 1 is 1, so 1 into 1 is 1, here also 1. So basically R0 value initially it will be 1 here now. Okay, so R0 value will be 1. This 0, to store it in R1, R0 previous value will be moved here, it is 0. You understand? 0 XOR with 1, that is 1. So again it will be moved to here, the value of here is 1 and the value of here is also 1. Okay, that's why all ones will get. Now again the process repeats. You understand, right? So same way, now what happens is, okay, now all the values here, what are the values? 1 1 1 from the from same way. Now the last bit will be sent and the XOR with this 1 1, and what is the result we'll see, like that we'll do. So that last bit also 0 1 1, right? So we got all this data into it. But now what we need to do, all the data is entered into the circuit. Now we need to change the enable bit to 0. Okay, and also the commutator is connecting here, right? So now what happens, this will be connected to here. Okay, so basically what happens at the end of the after all those shifts, the values in the registers are 0 1 1. Okay, 0 1 1. So now what you need to do, this connection will be going up. So basically I need to get all this value out. So how to get general, no, normal operation only, because anyways this value will be always 0, that's why it will, what happens, nothing will be there. all the values that is entered will be 0. That means when it entered 0 here, this will be shifted to the next, again it's 0, again it will be shifting to this side, like this. One bit it will come outside. Okay, so see what happens when I try to print here. One will be coming out, one will be coming out, one will, so first one will be coming out, next this, right? So again if I try to shift outside, one, like slowly one bit is going outside, like that. Okay, initial what happens when it is 0 1 1, next when I try to write, when I try to write the next, what we'll get, we need to basically normal shift only, 1 1 0. Okay, 0 0. Now again what we'll do, we'll shift this here, we'll shift this here, we'll shift this here. That means this one bit is went already, went into the channel, that's why it is missing here. Okay, so basically this will be one sent here, this will be sent here, this will be sent here. Okay, in the same way again all those bits. So basically how many registers? 3 registers, so therefore there will be extra 3 rows, 3 times you need to shift them. So then what we will get, 1 0 0 1. Again what are the data, what are the bits that is in the last row here, 0 1 1. So this is the code vector. Basically you can write directly also this, but be careful, you need to write the steps, right? Total 7 will come total. Okay, that means from 1 to 7, right? Total 7 will come. In the content dot there are basically there are n bits, right? So basic n bit of code word, so that's why you got 7 bits of code word, that's why you got 7 cycles. Okay, when okay, like that we need to do. So this is for the another message bit. Now syndrome calculation. So to do the syndrome calculation, what we need to do is, for syndrome calculation also same way, first we need to find what is s of x, that is the remainder of received data by generator polynomial. So first we need to take the received polynomial, what it is received, divided by generator polynomial, will get some remainder, right? That remainder is called syndrome polynomial. Okay, that so according to the circuit, how to connect is in the same way. So basically how many bits remain, right, there will be this is n minus k syndrome calculation circuit. That means n minus k syndromes are like n minus k registers will be there. So n minus k is 3, that's why s0 s1 s2. Okay, first we need to write those blocks, and then same way how you wrote for generator matrix, that is g0 is equal to 1, g1 is equal to 1, g2 is equal to 0, g3 is equal to 1. Here what we are taking, g0 we got. Okay, g0 is written in the separate, in previously for that code word we connected g0 with the s0 only itself, but here we will connect another, we'll take so basically there are n minus k that is s0 s1 s2, right? Now what we need to do, gains. So for here, for a syndrome circuit, okay, this is syndrome circuit. For this we'll insert here modulo 2 adders. So like this only. Now what happens, now we need to draw the gains. So that is generator polynomial vector. So first here g0, g1, g2. Okay, now g3 is anyways here, there will be the connection here. There actually there is no need of any XOR operation here, that the data will be splitted. Okay, So basically that wire is here, that wire. Okay, we'll just connect here. This one is called G3. Anyways, in this G2 is 0, right? So that's why I'll take out this 0 arrow. So what happens now? Again, this will be the one of the input of the AND gate, and this will be AND gate. The output will be like this, right? This is the input here. Data inputs. So here we'll get. So here what we have to do? Here there will be one more split. It is also AND gate. This will also enable pin. Here it is enable 1 and it is enable 2. And we'll get an output as S. Okay. So this is a syndrome. So same working. What happens initially? The data received. So the received data, for example, some n bit is there, no? So that is 1 1 0 1 0 1, right? So 1 by 1 bit it will enter, and initially what happens, all the SO will be 0. That means here G3 is 1 and it will be 0 because it is 0. So 0 into 1. Initially what is the first step is, here two enable pins are there. Now first we need to turn off, this is off initially and this is on. So only it will go upside 0. So again 0 into this will be 0 here. Okay, so now what happens, the input bit is 1 XOR with 0, that is 1. The value of X is 1, and then the same way this is also 0. So this is 0 into 1 is 0, that's why the value here is 0, and one of the input, what is the value here previously? 0, right? Because when it comes 1 here, it will be placed here and the value inside it will be shifted to the next block here. So here the value will be 0 into 0 1. So initially 0, that will be sent here, like that. Same way what we have done. After sending all these, what we'll do, we'll get a syndrome. Okay, when you do all these rotations, until all these bits entered, at the last rotation, at the last iteration, we will get some value, that is 0 0 1. That is the location of not location, this is a syndrome. Okay, 0 0 1 is the syndrome. That means after doing all the inputs given into the circuit, at the 7th, that is the last iteration, we will get the matrix, sorry, that syndrome. So how to do is the same way. This is the syndrome. We'll check this with the H transpose matrix. The 0 0 1 is on third position, that means third bit is in error, like that. This is the circuit way. Okay, this is how we will do for the circuit. In general, if you want to do it mathematically, so what we do, we just find the S of X, that is remainder into R of X by G of X. The remainder of R of X by G of X, we will get a remainder. That remainder is called syndrome. Okay, not syndrome polynomial. Let us take some S of X. Okay. For this question, the X of X was got as X square. So S of X in binary can be written as 0 into X naught plus 0 into X power 1 plus 1 into X square. So 0 0 1. So in the H transpose matrix, 0 0 1 is in the third row, like that. So third bit is in error. Okay, the same way how we are trying to here error correction is, we will first third bit, right? So error vector, in the error vector the third bit will be 1, remaining all will be zeros. So as R XOR with E, we will get the corrected code word here. So this is how we will do. Thank you for watching. Like, share and subscribe.